Welcome back, everyone, to the deep dive. Ready to get a little nerdy with me today?
Always ready to dive in. What have you got for us?
Well, we're going to be tackling a paper that really gets into the nuts and bolts of how we can make language models better. Not just in theory, but in how they actually work out there in the wild.
Sounds right up our alley. What's the title?
It's called InfAlign, Inference-aware language model alignment. Bit of a mouthful, but trust me, the ideas are really interesting.
Okay, I'm intrigued. Who are the authors?
So it's a team from Google DeepMind and Google Research. Ananth Balashankar, Ziteng Sun, and a bunch of other really smart folks.
The usual suspects. I've seen some of their work before. What's this one all about?
Well, they're tackling a kind of unique challenge in language model alignment. See, most of the time, we focus on making sure the model's output is better than the original untrained model. Like we're just aiming for improvement.
Right, that makes sense. You've got your baseline and you want to see how much better you can do.
Exactly. But what if you're using a more sophisticated way of using the model? Like what if instead of just taking the first output, you generate a bunch of different outputs and pick the best one?
Ah, I see. Like a best of N kind of situation.
Yeah, exactly. Or what if you're actually trying to find the worst possible output, like to test for safety issues? That's where things get really interesting, and that's where this paper comes in.
Interesting. So they're saying that our standard way of training these models might not be the best way if we're using these more advanced techniques.
Exactly.
Okay, so how do they propose we address this? What's their solution?
Well, they've developed this new framework they call InfAlign. And the basic idea is that you need to optimize the model for how it's actually going to be used.
So you're not just training the model in a generic way, you're training it with the specific inference-time algorithms in mind.
Exactly. It's like tailoring a suit,
right?
You wouldn't just use generic measurements. You'd take into account the individual's posture, their style. InfAlign does the same for language models.
That's a great analogy. I'm starting to get the picture here, but how do they actually implement this?
So the interesting thing is they found that you can actually solve this problem of aligning the model for different inference methods by simply changing the way you calculate rewards in the reinforcement learning process.
Wait, hold on. So they're not proposing some radical new training method. It's all about tweaking the reward system.
That's right. They've got this algorithm they call CTRL, stands for calibrate-and-transform reinforcement learning. It's got 3 steps to it.
3 steps. All right. Break it down for me.
Okay. So first, you've got reward calibration. This is where you kind of adjust the rewards to make sure they're all on the same scale, like calibrating a wonky measuring stick.
Got it. Make sure everything is standardized. What's the second step?
Then you've got reward transformation, and this is where it gets really interesting. Here, you actually change the shape of the reward function based on what you're trying to achieve.
Okay, so you're tailoring the reward to either emphasize high rewards, like for best of N, or to emphasize low rewards for something like worst of N.
Exactly.
Makes sense. And the third step?
Third step is reinforcement learning optimization. This is where you just use standard reinforcement learning algorithms, but you use the transformed rewards to guide the model's learning.
Got it. So it's the same training process, just with a different reward signal.
Right. And here's the cool part. They tested this out on these Anthropic datasets, which are used to evaluate helpful and harmless dialogue.
Yeah, I'm familiar with those. They're pretty comprehensive.
And they found that their CTRL method not only matched or beat existing methods on the standard benchmarks, but it significantly outperformed them when using these best of N and worst of N techniques.
Oh, wow. So it actually works in practice. That's impressive. How much better did they do?
For best of N, they saw like 8 to 12% improvement, and for worst of N, it was 4 to 9%.
Those are some serious gains. This is really interesting stuff.
I know, right? It's like they found a way to make these language models so much more adaptable to how we actually use them.
Definitely a big step forward in the field of language model alignment.
Absolutely. And this is just the beginning. We're going to get even deeper into the details after the break, so don't go anywhere.
You know, one of the things that really impressed me about this paper is how much they dug into the theory behind it all. Like, they didn't just say, hey, here's a new framework. They actually went and proved mathematically that this whole thing works.
Hold on, slow down a sec. Mathematically proved. What do you mean by that?
So they showed that for any inference time procedure, like whether you're doing best of N or worst of N or like really anything else, you can find a specific way to transform those reward signals during training that's going to give you the best possible results for that specific way of using the model.
Okay, now my brain is doing backflips. So they're saying that you can tailor the training process to be perfect no matter how you plan to use the model later on.
Exactly. It's a pretty elegant result, actually. And they didn't just stop at the theory either. They went on to derive the exact reward transformations you'd need for best of n and worst of n specifically.
Wow, okay. So they've got the equations to back it all up. Color me impressed. But can we maybe get back up a little? All this talk about reward transformations is making my head spin. How do they even figure out what these transformations should look like?
Yeah, it's definitely complex, but it's also pretty cool how they do it. They use this idea of calibrated inference-time procedures. Basically, what that means is that you're looking at how the different outputs are ranked in terms of their rewards, rather than the specific numbers themselves.
So, like, it's more important to know which output is the best, second best, and so on, than to know their exact scores.
That's a great way to put it. And because of that, the whole process becomes independent of whatever specific reward model you started with, or even how well your initial language model was doing.
Wait, really? So it doesn't matter what your baseline is, you can still apply these transformations and get better results.
That's the idea. And they actually tested this out empirically using a simplified language model. They tried out different reward transformations to see which ones worked best for best of n and worst of n.
So it's like they're using this simpler model as a testing ground to figure out the rules of the game.
Yeah.
And then they could apply those rules to the big complex models out there in the real world.
Exactly. And what they found is that these exponential transformations, where you have a positive exponent for best of n and a negative exponent for worst of n, those worked incredibly well.
It all comes back to that idea of boosting the high rewards when you want the best outputs and emphasizing the low rewards when you're looking for the worst. Makes sense to me. But how does this actually play out in the real world? Like, how do they actually incorporate this into the training process?
Well, that's where the CTRL algorithm comes in. It's a way to take all of this theoretical stuff and make it practical. They use this really clever technique to approximate the rewards based on just a small sample of outputs, which makes the whole thing much more efficient computationally.
So they're finding ways to make it work without needing a supercomputer to crunch all the numbers.
Right. And they showed that it works really well, too. Remember those results we talked about on the Anthropic datasets? That was using this CTRL algorithm.
Yeah, those were some pretty impressive improvements. Now I'm even more impressed knowing that there's this whole theoretical foundation behind it. But one thing I keep wondering about is this whole issue of reward hacking, which I've heard is a big concern with language models. How does all of this relate to that?
That's a really great question. Reward hacking is basically when the model figures out how to game the system. Like, it finds a way to get a high reward without actually understanding the task or doing what we want it to do.
Right. There's like a student figuring out how to cheat on a test without actually learning the material.
Exactly. And one of the cool things about this InfAlign approach is that because you're directly optimizing the model for the specific way you're going to use it, it becomes much harder for the model to do that kind of reward hacking.
So if you train the model with best of n in mind, it's really going to focus on generating those high-quality outputs, not just finding some shortcut to get a high reward.
That's right. And the authors actually did some experiments where they deliberately tried to trick the model into reward hacking by putting misleading information into the training data, almost like setting traps to see if the model would fall for them.
Okay, that's sneaky. What happened? Did it work?
They found that the models that were trained using calibrated rewards, those were much more resistant to these manipulations. They didn't fall for the traps as easily.
So it's like the calibration process not only makes the rewards more accurate, but it also makes the model more robust to these kinds of shenanigans.
Exactly. It's a really encouraging sign that this approach could lead to more reliable and trustworthy language models in the future.
This is all pretty mind-blowing stuff, but, got to ask the tough question here. Is InfAlign the end-all, be-all solution to language model alignment? Are we done?
Well, it's definitely a big step forward, but like any research, there are still some limitations and open questions. One thing to keep in mind is that this paper mainly focused on those inference methods that are based on ranking the outputs, like best of n and worst of n.
So we don't know how well this would work for other ways of using language models, those that maybe aren't so focused on ranking.
That's right. That's one area where more research is needed. Another open question is how to handle situations where you have multiple different reward signals that you're trying to optimize at the same time.
Right. Like, what if you want the model to be both helpful and safe, or both creative and factually accurate? How do you balance all those different goals?
Exactly. How do you calibrate and transform those multiple reward signals to get the best possible balance? That's a tough problem that researchers are still working on.
So InfAlign is a powerful new tool, but it's not a magic bullet.
I think that's a fair assessment, but the research that it has sparked is incredibly promising and could lead to some really big breakthroughs down the line.
Yeah, it's definitely got me thinking about the future of language models and how we can make sure they're not just powerful, but also aligned with our values and our goals. This whole field is moving so fast, it's hard to keep up.
It is, and it's only getting more exciting. The work that's being done in language model alignment is so crucial for ensuring that these technologies are used for good.
Couldn't agree more. Okay, well, I think we need to take a breather for a moment and let all of this sink in. This has been a whirlwind tour. There's some pretty complex stuff. Okay, so we've gone pretty deep into the technical side of InfAlign, but I want to bring it back to the people who are actually using these language models every day. What does all this mean for them? What's the takeaway?
Well, I think the big takeaway is that we're getting better at making sure these models behave the way we want them to, even when we're using them in more complex ways.
So for developers who are building applications that rely on these models, this gives them more confidence that things are going to work as expected.
Exactly, and that's super important, especially as we see these models being used in more and more critical areas like healthcare, finance, education, you name it.
Right, the stakes get a lot higher when these models are making decisions that could have real-world impact.
Absolutely. And it's not just about reliability either. This whole approach also opens up some really interesting possibilities for how we can optimize models for specific tasks.
So, like, could you use InfAlign to train a model specifically for medical diagnosis or for legal research, something like that?
Exactly. By tailoring the alignment process to how the model is going to be used, you can potentially get even better performance and accuracy.
That's pretty cool. It's like giving these models specialized training for each job they have to do.
I like that analogy, and I think we're only scratching the surface here. As research in this area continues, I'm sure we'll see even more creative and powerful applications of this framework.
Yeah, this is all really exciting stuff. It feels like we're moving towards a future where language models are not just incredibly powerful, but also, trustworthy, aligned with what we want them to do.
I couldn't agree more. This research is a great example of how we can use really thoughtful design and collaboration to shape these powerful technologies for good.
Absolutely. Well, on that note, I think we've covered a lot of ground today. We started by looking at the limitations of the standard way we align language models. Then we dug into this new InfAlign framework. And we even talked about the ethical considerations around things like reward hacking. It's been quite the journey.
It has, and I think it highlights how important this work is. As these models become more and more powerful, it's crucial that we keep thinking about these issues and working to make sure these models are aligned with our values.
I'm with you there. Well, that's all the time we have for today, folks. But if you want to learn more about the nitty-gritty details of InfAlign, we'll be sure to include a link to the paper in the show notes.
And if you have any thoughts or questions, please come join the conversation on our social media. We'd love to hear from you.
Definitely. I always love hearing from our listeners. All right, thanks for joining us today for another deep dive. Until next time.